Today, I'm really excited to talk to the probably most important scientist in the field of human evolution, brain development, brain health, all related to one of the most important, if not the most important, omega-3 fatty acid, the DHA. It is Professor Dr. Michael Crawford from the Department of Metabolism, Digestion, and Reproduction of the famous Imperial College in London. Now, for his exceptional scientific work, he has been honored with numerous international awards, like, for instance, in 2018, the Global Award for Research on Omega-3 and Neuroscience by the Much Love Foundation in China. In 2017, he was honored as Freeman of the City of London. In 2016, he received the Alexander Leaf Distinguished Scientist Award for Lifetime Achievement at the ISFAL conference in Stellenbosch, South Africa. And in 2015, actually, he was even honored by the Emperor of Japan with the Order of the Rising Sun, and he received the Chevreul Medal in Paris. So you see, there are a lot of prizes and honors for this gentleman. But I could go on, but time is very precious. And now I would like to welcome Professor Crawford. Thank you for your time and joining us.
Thank you. Thank you for that introduction. Now, you have questions?
Yes. Now, I would like to start off with the first question. Omega-3, particularly DHA, and the evolution, why was DHA actually so important for the evolution of mankind? What is the story behind it?
Thank you, Peter. Well, why is DHA important in evolution in general? Well, it starts 500 million years ago when the origin of photoreception as we know it today occurred in the Cambrian oceans. Now, for the first 2.5 billion years, the planet was occupied by photosynthetic systems, and they converted sunlight into carbohydrates and proteins. And the trick was oxidative metabolism, which enabled nature to build all these complicated unsaturated fatty acids. You got, for example, DHA would require 6 oxygen atoms just to remove the hydrogens for the 6 double bonds. So it wouldn't have been made in any abundance in the Precambrian era. But come oxygen, it could have been made without too much difficulty. And so what we now see is that in the dinoflagellate, it has the same chemistry in its eyeball spot as you have in your eyeball. And it converted, or something like it, converted 500 to 600 million years ago, sunlight not into carbohydrates and protein, but into electricity. And that sparked the evolution of the nervous system and ultimately the brain. So in terms of evolution, it is completely incontrovertible that Homo sapiens could not have evolved a large brain without having access to a source of DHA-rich foods. I think that is the story. We couldn't have done it without.
Okay. And so basically you would say that modern human Homo sapiens actually really developed more on the coastlines.
Yes. I think that there's abundant scientific evidence for this. And there's also stuff from South Africa, from Pinnacle Point, for example, where Curtis Marriott and others have discovered caves that were occupied by the earliest known humans, with evidence of cultural symbolism and so on and so forth in these caves, and also evidence of them making incontrovertible evidence of making extensive use of the marine food web.
Right.
And that was 160,000 to 200,000 years ago. And you see, the chimpanzee, we share a genome with only 1.5% different. It only got 350 grams of brain. And you can't explain going from 350 grams to 1.4 kilograms without the building materials. And we had to have the marine food web at our beck and call in order to build that brain.
Right, right. And so obviously I've got here as a question, why is DHA so important and abundant, present in the brain and the eyes? But the question would be, could it be actually replaced by any other polyunsaturated fatty acid?
Say that again?
So we have a lot of DHA in the eyes and in our brain.
Yeah, yeah.
Now, what would happen? Now, let's imagine for some reason we would run out of DHA.
Oh.
Could this be replaced, the DHA, could it be replaced by, I don't know, for instance, EPA or DPA?
No.
Or arachidonic acid?
No. I mean, nature has had 500 to 600 million years of evolution when she could have replaced it with almost anything that you might like to. Even the docosahexaenoic acid, for example, which is a precursor. It's only got one double bond less than DHA, but has never been used over those 600 million years. So it's, to my way of thinking, that evidence is supremely strong in saying that DHA is pretty irreplaceable in terms of the vision and the signaling systems of the brain.
Right. Now, we're living at the moment in Spain, and we're also at my little company over there. And we're noticing that many young people, young ladies, they don't eat fish anymore. And they don't take necessarily DHA supplements. If you think further, is that a problem actually for us, for our brain cells? Because basically, where does that baby get the DHA for its brain from?
Yeah, I'm afraid this is something that is happening at the moment, but not just now, but in the UK, for example, in 1950, shortly after World War II, we landed 1.1 million tons of fish into the UK. In 2019, a couple of years ago, it was only 600 and something tons. But the population has expanded, and there's been a huge disconnect with the balance between what you get from the land and what you get from the sea. Both are important, but both need to be balanced. And I'm afraid that what has been happening in recent times is that mental ill health has been rocketing. In 2004, the European Union decided to do an audit to build health. And it, when the answer came out, it had brain disorders, top of the list at 386 billion euros. And you'd expect somebody would have said, well, hey, we should do something about this. After all, the brain makes us different from other animals.
Yes.
But all they did was complain and say, oh, it's just due to modern psychiatric analysis and things like that. So they did the numbers again in 2010, and it turned out at 789 billion. And you've got the same story in the UK. 2007, it was 77 billion. In 2013, it was 113 billion. Just the cost of mental ill health alone in the UK. So this is deeply worrying because it cannot go on. The logical extension of increasing mental ill health and brain disorders is the end of humanity. It's just simple, sheer logic, and we've got to do something about it.
And you see a direct correlation and relation to the DHA?
But the DHA, I mean, it has to be that. I mean, because the really modern, intensively land-based food production, which has taken over, if you like, in recent time, and been extremely successful. And it's really important to realize that the success has been phenomenal. To be able to feed 12 million people in a city just the size of London and no more every day, or Tokyo or New York, it's just phenomenal. And they do it every day. And so one doesn't want to knock the food industry, but the reality is that it's gone wrong. And the balance between what we got from the sea and what we get from the land has just gone wrong. And that it has to be the cause of this rise of mental ill health.
And so if basically the only substantial source of DHA is really a marine source.
Yeah.
And that goes back, I think, basically to the algae in the seas, right? So would it make sense to establish kind of algae farms to build up the DHA pool in the oceans?
Yeah, there are actually, if I may say, just as a passing by, there are actually land-based sources of DHA. Right. Small animals can make DHA. It just peters out when you get into the big animals. They grow too fast, so they can't make it. And that's why their veins all shrink and they've only got tiny brains. But the answer, I think, has to be that we need to, what the Japanese minister said when we discussed it in Japan in 1990, we need to agriculturalize the oceans. The Foresight report on the future of food and farming came to the conclusion that there really isn't new arable land available or land available for arable use to meet the expanding populations that we have at the moment. And given that, I think one has to recognize that, the planet is 71% water. And we need to make use of the marine environment. And the Japanese are doing this. They're farming the sea. They're farming the land, growing marine grasses for the fish to eat in the same way that we grow green pastures for the cows to eat. Okay. And they grow kelp. The kelp is used for many reasons. It can fertilize the land. It can be used for food. It's rich in trace elements. And not only that, it fixes CO2. So you have an answer to, or at least some contribution to fighting ocean acidification and CO2. So the case for marine agriculture, what some people call mariculture, is extremely powerful because we've been ruining the sea in the past. And the Japanese have shown that you can restore the seabed that has been killed by trawling and so on and so forth, and by pollution, that you can restore it and in an ecological manner encourage the production. And not only does this provide new food, but it also provides, of course, DHA and all the trace elements that are important. And you get not only fish, but you also get the seafoods like lobsters, crabs, oysters, mussels, scallops, and so on and so forth. It's just phenomenal what could be done if we could put our mind to it.
Yes, I agree. I absolutely agree.